Hello everybody, my name is Miss Dokmanovic and I will be teaching you today. So we're going to continue learning all about equal groups and how to represent equal groups using a repeated addition expression. So I've brought a little friend along with me today. His name is Little Ducky. Can you give him a wave? Oh, excellent, thank you. Now, Little Ducky's a little bit shy. He loves maths, but sometimes he makes mistakes. So your job today is to help him out when this happens. Do you think you can do that? Oh, great, thank you everybody. So we'll see more of Little Ducky later on in the lesson. Now let's review the practice activity from the previous lesson taught by Mrs. Perry. So she asked you to represent 4 groups of 6 with a drawing, a bar model and a repeated addition expression. She then asked you to do the same to represent 6 groups of 4. Now I hope that you've got your drawings and pictures in front of you. I want you to have a look at what you've done and have a look at what I decided to do to show this. And I want you to have a think about whether it's similar or different to your example that you've done. Have you noticed that with my example, in the top picture, we've got 4 equal groups. And in the bottom picture, we've got 4 dots in each group. And have you also noticed that in the top picture, there are 6 dots within each group, but in the bottom picture, there are 6 equal groups. So for that bottom example, we've just swapped the number representing the number of groups with the number representing the group size. And do you remember that Mrs. Evans' puppet Number Bear found this a little bit tricky in her lesson? Let's have a look at these 3 pictures. We can see a picture of some coins. Now we've been learning a lot about money recently, haven't we? Do you remember what the value of a 2-pence coin is? That's right, 1 2-pence coin has a value of 2p. So we don't need those pre-money tokens anymore now that we've gone over that. So we can also see a picture of some children in some bumper cars with a repeated addition expression underneath. And we can see a picture of some blue counters with a number underneath. So first of all, I want you to have a look at all 3 of those pictures and I want you to think about what's the same and what's different about them. And then I'd like you to pause the video and explain this. Okay. Now let's have a look at the picture of coins first. How many 2p coins can you see? That's right, there are 2 2p coins. Do we remember our sentence stems from lesson 6? Let's see if we can use them to help us to describe this picture. Now, I want you to say the sentence stems with me, okay? So remember to speak loudly and clearly, otherwise I won't be able to hear you. Let's have a go. There are 2 groups of 2. There are 2 and 2. We can write this as 2 plus 2. Excellent. Now let's have a look at the picture of the bumper cars. How many bumper cars can you see? There are 2 bumper cars. And how many children are in each bumper car? There are 2 children in each bumper car. So let's see now if we can use the same sentence stems to describe this picture. Off we go. There are 2 groups of 2. There are 2 and 2. We can write this as 2 plus 2. Now, have you noticed what's the same about this picture of coins and this picture of bumper cars? So there are 2 2p coins and there are 2 bumper cars. Each 2-pence coin has a value of 2p and there are 2 children in each of the bumper cars. So we can use the same sentences, can't we, to describe both of these pictures, even though both of these pictures show different objects. Now let's have a closer look at these blue counters. How many blue counters can you see? That's right. I'm sure most of you got that answer straight away. There are 4 blue counters, and we can see that really clearly, can't we? And I don't know about you, but they remind me of a pattern on a dice. So little Ducky has noticed something about these blue counters that he wants to tell me about. Little Ducky says that he can see 2 groups of 2, and I wonder if some of you have seen these counters as 2 groups of 2. Now little Ducky's going to show you what he means by this. So he's going to draw 1 group of 2 by circling 2 counters, and then he's going to draw another group of 2. And by doing this, he can say that he can see 2 groups of 2. Now there's another way that we can show those groups of 2, and I wonder if you've thought of it already. I'm going to show you now. So we can show our groups of 2 in a different way by drawing our groups like this. And we've still got 2 groups of 2, haven't we? Some of you might have seen it differently, and you might have even seen 4 groups of 1 because there are 4 blue counters. Let's think carefully about that number 4. What do you think the 4 represents in this picture? The 4 represents how many counters there are in each group. So what does that tell you about the number of groups? There are 4 counters in each group, so that must mean that there are 4 counters in one group. And I'm going to show you how that can be represented. So I'm going to draw my 1 circle, making 1 group around my 4 blue counters. So let's use that sentence stem again to describe this picture now. I want you to say it with me. There is 1 group of 4. The 1 represents the number of groups, and the 4 represents the number of counters in the group. Now, if there's only 1 group of 4, do you think that we can use a repeated addition expression to represent this? We can't, can we? Because we are not adding the same equal group again. There's only 1 equal group here. So this is why the picture of the counters is a little bit different to the picture of the coins and the picture of the bumper cars. With the counters, there is 1 group of 4, and with the coins and with the bumper cars, there are 2 groups of 2. Now I want you to have a look at this picture. What have you noticed? There are lots of pineapples in some boxes, aren't there? Do you like pineapples? I do. They're one of my favourite fruits. Okay, so we've got a true and a false question for you now. I want you to have a look at that statement. Shall we read it together? This picture shows 5 plus 5 plus 5 plus 5. Now, do you think that's true or do you think that's false? In a moment, I want you to explain your answer. Pause this video and then we'll come back after you're done. Shall we see if you got it right? Okay. Well done if you said that this statement was true. But how do we know it's true? Shall we use those sentence stems again to describe the picture? They've been really handy, haven't they? And helped us with our reasoning. Okay, let's have a go together. There are 4 groups of 5. There are 5 and 5 and 5 and 5. So have a look at the number of 5s we've got. We can also say that there are 4 5s. Now I bet you can think of the repeated addition expression now. Let's say it together. We can write this as 5 plus 5 plus 5 plus 5. So I want to know, what does each 5 in the repeated addition expression represent? Each 5 represents the number of pineapples in each box or each group. There are 5 pineapples in each box. So why are there 4 5s? There are 4 5s because there are 4 groups of 5. There are 4 boxes of 5 pineapples. Now I'm going to write the number 5 next to each box of pineapples. So I've got my second 5 here. I'm going to write my third 5 and my fourth 5. So 4 groups of 5. Now here's another question. We've got another true or false question, but I bet you'll be really good at this one. So have a look. We've got a different picture this time. What can you see? There are lots of trees with apples in them. I wonder if any of you have any apple trees in your garden. So let's have a look at that first statement. Shall we read it together? There are 6 groups of 2. So I want you to have a think. Is this true or is this false? Does that statement match the picture? And you might pause the video here to explain your answer. Shall we see if you're right? Are you ready? Okay. Well done if you realise that it was true. Shall we use our sentence stems again? Let's have a go. There are 6 groups of 2. So we know that it's true, don't we? But to explain it further, what does the 6 represent? The 6 represents the number of trees, doesn't it? Shall we count how many trees there are together? 1 tree, 2 trees, 3 trees, 4 trees, 5 trees and 6 trees. So what does the 2 represent? The 2 represents the number of apples in each tree. Okay, can you help me with this sentence? There are 2 and 2 and 2 and 2 and 2 and 2. Wow, that's a lot of 2s. That's a really long sentence, isn't it? I wonder how many 2s there are in that sentence. Can you count them and check? That's right, we can say that there are 6 2s. So now I want you to have a look at that second statement underneath the first one. It says, we can write this as 6 plus 6. Now, little Ducky thinks that we can write this as 6 plus 6. He thinks that the statement is true, and he's very sure about that. Now, I want you to have a think. Is little Ducky right, or has he made a little mistake? Is there a different repeated addition expression that we can write to match this picture? Have a think, pause the video, and have a go at explaining. Okay, shall we see if you're right? Little Ducky, are you ready? You're sure you're not going to get sad if you got it wrong? Okay, excellent. Let's see. It's false. Oh, and little Ducky's looking a bit confused about this, so shall we help him to understand? Okay, let's have a go. So now we've got these sentences underneath the picture. It might be quite easy to know what that repeated expression should be. Shall we have a go at saying it together? We can write this as 2 plus 2 plus 2 plus 2 plus 2 plus 2. So 6 2s. Now, if I was going to write 6 plus 6 to match a picture of trees and apples, what might that picture look like? Now, I've got a challenge for you. I want you to think about that expression, 6 plus 6, and I want you to get some paper and a pen or a pencil, and I want you to draw a picture of trees and apples to match this expression 6 plus 6. And when you're finished, come back and we'll see if your picture looks like mine. So here's my picture to represent the expression 6 plus 6. Does it look like the picture that you've drawn? I hope so. So, have you noticed that I've got 2 trees and I've got 6 apples on each of my trees? Have you also noticed that the apples on my trees are of different sizes? Some of them are bigger than others. But remember, it doesn't matter about the size of the apples as long as you've got 6 apples on each of your 2 trees. Now, let's say a sentence or two to go with this picture. Let's say it together. There are 2 groups of 6. There are 6 and 6. We can write this as 6 plus 6. So that helps us to understand why the picture would look a little bit different to the first one. And now let's have a look at both of the pictures together with their repeated addition expressions. So here we can see that bottom picture, the 6 plus 6, is very different to that top picture, isn't it? And we need to be really clear on what the numbers within the repeated addition expressions represent to get it right. What can you see in this next picture? We can see some coins in a purse, can't we? Now, let's have a read of the question together. Sam has drawn a bar model and written an expression to match the picture below. Is he right? I'm not sure if he is right. Now, can you be a detective and can you take a closer look and see what mistakes Sam has made with his bar model and with his repeated addition expression? If you're not sure, I'll give you a clue. Look closely at the type of coin Sam has in his purse. Are they 1p coins? No, they're not, are they? Are they 2p coins? No, they're not 2p coins either. Are they 10p coins? Yes, that's right, they are 10p coins, and we know this because we can see 10 pence written at the top of each coin, can't we? Okay, now it's time to pause the video here and talk about the mistakes that Sam has made. Okay, shall we go through this together now? Right, so we can see some 10p coins, can't we? Do you remember what the value of a 10 pence coin is? That's right, each 10 pence coin has a value of 10p. So how many 10p coins can you see in Sam's purse? Yes, that's right, there are 3 10p coins, or 3 groups of 10. So let's say a sentence to describe this. Are you ready? There are 3 groups of 10. We can also say this sentence. There are 10 and 10 and 10, and each 10 represents each 10p coin in the purse. Now, I bet you can say the repeated addition expression to match these sentences now, can't you? Shall we say it together? Are you ready? Okay. 10 plus 10 plus 10. So we can see now that Sam was a little bit right, wasn't he? Because he knew that he had to split that bar model into 3 equal parts. And he knew that for his repeated addition expression, he needed to have 3 numbers. But the mistake that he made was that he wrote the number 1 instead of the number 10. So this is what it should have looked like. Now he was almost there, wasn't he? Okay, and now it's over to you and it's time for your practice activity. So what I'd like you to do is to make your own true or false questions. I wonder if the grown-ups in your house are as good as you are at explaining your answers. Here's an example of what I've done, so I want you to have a good look at it. Can you see that I kept the number of groups and the group size quite small? Can you see that I have drawn the same objects in each of my groups? So I want you to make sure that you do the same thing, okay? And I'd also like you to bring your examples to the next lesson with you. Okay, I'm looking forward to seeing what you come up with. That brings us to the end of our lesson. So thank you very much, everybody, and it's goodbye from me and goodbye from Little Ducky.